All right, we're moving right along. Pre-calculus B, section 2-4, day 1. So just to get come right out of the gate strong, this whole quadratic formula business doesn't really apply until a different lesson. So I'm going to take the time to skip this. You might recognize that from Algebra 2. This doesn't really apply to today's work at all, so I'm going to skip it. But it will come up, and it might be the next section, but we'll cover that when we'll cross that bridge when we need to. This guy right here, complex conjugate zeros, is a really strange little statement. All it's saying is, and I'm going to just abbreviate this, is if you get if they tell you at some point, and I'm just going to be honest, this is kind of a weird deal. If they tell you that an equation or a function has a zero, something like 7 plus the square root of 2, then you are to assume that 7 minus the square root of 2 is another zero. It's implied. Now, if you recall, this is the only application from the quadratic formula, but you notice this is negative b plus or minus the square root of b squared minus 4ac. So I'm just going to say there's like a possibility you could get negative 3 plus or minus the square root of 7 all over whatever, 2. So, moving backwards, if math simply tells you that negative 3 plus the square root of 7 over 2 is one of your zeros, then you are to safely assume that negative 3 minus the square root of 7 over 2 is another zero. Basically, piggybacking the quadratic formula. It's just something kind of weird. Another one would be like 7 plus I, because what is I? The square root of negative 1. So then you could say, aha, so that means 7 minus I. Keep that in mind as we keep going. So we're going to go down here, and I'm going to start explaining this. It says, write the polynomial in standard form and identify the zeros, got to talk about that, and the x-intercepts. Now, if we take a look at the xy axis, understand that every single point on the x-axis are real numbers. That's what this is indicating. Identifying the zeros means all zeros, real or imaginary. So, with that in mind, I think the wise thing to do would be to do this first, and then we will pick out our real zeros. That is another word for our x-intercepts. Because if you think about it, any point on the x-axis, any point, we know something about it. Y equals 0, y equals 0, y equals 0. So really what you're doing is you're setting this equal to 0, and you're asking yourself, okay, what would cause this to actually equal 0? Well, for this one, it'd be 6i. For this one, it would be negative 6i. Now notice these are not real, so they are not x-intercepts, but these are what's called zeros. I know it's a little confusing. These cause the equation to be zeros, but they're not actual x-intercepts because they're not real. So x-intercepts, they don't exist. There's none, okay? Just kind of language just to get started, but it does say right here, write the polynomial in standard form. What does that mean? It just means multiply it out. So we're going to do that. So if I have x minus 6i, x plus 6i, I'm going to FOIL this out, so I get x squared, and I get plus 6i minus 6i. A negative times a positive is negative 36i squared. Now, do you guys remember what I squared equals? I squared equals a negative 1. How come? Because I equals the square root of a negative 1. And if you square a square root, these little roots fly off, and you get negative 1. So these would cancel. This is negative 1. So I would end up getting f of x equals x squared plus 36. All right, let's move on to this next example here. Same sort of thing, same jam. We're going to start out by identifying all our zeros. So we just look at this and we say, okay, so here come the zeros. Negative 2 and negative 2, and then I, and then negative I. Now, the x-intercepts, you look for the real zeros. So that'd be negative 2. If you want to get fancy, it'd be dr, standing for double root, because it happens twice. And then we just multiply this all out. Now, I like these first because these are considered conjugates, so I can just because if I FOIL it, the outside and the inside, as you can see, would just cancel. So x times x is x squared. Be careful here, that'd be minus I squared, which is the same thing as x squared. Remember, I squared is negative 1, so it's x squared minus a negative 1, which is plus 1, times, now I'm going to do this kind of in my head, x squared. Now I'm going to go outside and inside, giving me 4x plus 4. And now I've got one of those situations where I got to do my 2 by 3 box. But in this case, I don't have much room, so I'm just going to do it a little different. This needs to just distribute to everything. So I get x to the 4th plus 4x cubed plus 4x squared. Now I'm going to distribute that 1 to everything. Essentially, it's just all of these. So I'm going to line them up. X, my like terms, plus 4x plus 4. And I'm going to add like terms. Can I squeeze it in here? So I would get f of x equals x to the 4th plus 4x cubed plus 5x squared plus 4x plus 4. And there we have it. All right. This next one, this one says, write a polynomial function of minimum degree in standard form with real coefficients. Well, that's a lot of information. Given the zeros. All right, we got to dummy this down. Now, this is going to be a little bit confusing, but this is going to be where the complex conjugate zeros thing pops up. And I want you to look at this. 7 plus I, we are to assume that 7 minus I is a different zero. That's significant because we're kind of working backwards here. But this is not a complex zero. So we know right away, I'm going to use g of x. That one is going to refer or translate to that. Because if I put a 3 in there, that would give me one of my zeros. But if I look at this 2i, I need to kind of see it as 0 plus 2i. Because this is a complex conjugate zero, where I'd have 0 minus 2i as another answer. All that's saying is I need to go x minus 2i and then x plus 2i. And that's a little tricky because that's all hinging on this sneaky little statement up here. So math's just being a little tricky on you. Now I just got to multiply it out. That's what all the rest of this is saying. So here are my conjugates right here. And when you have conjugates, you can foo instead of foiling. So I'm going to go x times x is x squared. A negative times a positive is minus 4i squared, which is the same thing as x squared plus 4, because I squared equals negative 1. And that's going to be times x minus 3. And now I just FOIL. So x cubed, and I might as well go, just to put things in order, I'm going to go here first. Minus 3x squared, and then outside, and then minus 12. And I'm just going to call it, well, I already called it g of x, so I'll stick with that. And that's it. So there we go. Example 4, right away we can see that negative 2, so we're going to go h of x equals x plus 2. That's what this comes from. Here's that darn complex conjugate rule, so that's got to include this. And they're not going to tell you that. You just need to know it. So, here's the weird part of it. Remember, if I say this, isn't it the same thing? And remember this, it's x, my 0, minus the actual 0. And that's kind of the rule. And you have to remember that when you're dealing with these really weird ones that are binomials. Because technically, we have to take our x, subtract all of it. So I'm going to write this as 1 plus 2i. And we did do one similar to this earlier, but now I need to do the same thing with this guy. So x minus 1 minus 2i. Now it's just a big old math problem. So I'm going to clean this up. So this is x minus 1 minus 2i. This one is x minus 1 plus 2i. And again, this would be still x plus 2. I'm going to take this guy, seeing I have a little bit of space here, try to make a 3 by 3 box. And that's x minus 1 minus 2i, x minus 1 plus 2i. So I get x squared minus x minus 2ix minus x plus 1, 2i, 2ix, negative 2i, and then here I get negative 4i squared. I'm going to write that over to the side because this is negative 1 times negative 4 is 4. Now here's something nice. These cancel, and these cancel. So it kind of cleans itself up pretty good, but I am running out of space, so I need to create some over here. So if I add my like terms together, I'm going to get x squared, that's gone, minus 2x. And then I add these together and I get plus 5. And I need to multiply that by x plus 2. And again, I'm running out of space, so I'm going to have to be sneaky here. So x cubed minus 2x squared, so that goes to here, and then plus 5x. Now I'm going to distribute this and this and this. So I get 2x squared minus 4x plus 10. Gotta stay organized. X cubed, cancel, plus x plus 10. And that equals my h of x that I started with. Now I'm running out of time, so I'm going to flip this over. Ooh, yeah, I'm going to run out of time, so I'm going to have part 2 on this. Sorry, guys.